Imagine holding a device in your hands that is 2,000 years old, yet possesses a level of mechanical sophistication that humanity wouldn't see again for another millennium and a half. In the year 1901, divers off the coast of a small Greek island pulled a calcified, green-encrusted lump of bronze from a Roman shipwreck that would eventually shatter our entire understanding of ancient history. This is the Antikythera Mechanism, a physical anomaly that exists in a museum today, yet remains a profound insult to the linear timeline of human progress. For decades after its discovery, the device sat in a storage box because it looked like nothing more than a corroded rock. But when X-ray imaging finally pierced through the layers of limestone and oxidation, it revealed a nightmare for traditional historians, a complex system of over 30 interlocking bronze gears, some with teeth as small as a millimeter. The sheer precision required to hand-cut these gears is something we associate with the Industrial Revolution, not the era of horse-drawn chariots and hand-woven tunics. But think about this for a second. If you were an ancient engineer, every single gear you carved would represent a massive investment of time and risk. One slip of the chisel, one miscalculation in the tooth count, and the entire machine becomes a useless pile of scrap. Yet the Antikythera mechanism isn't a prototype, it is a finished, polished, and highly optimized instrument. This implies that there wasn't just one of these machines, but an entire tradition of Greek high-tech engineering that has been completely erased from the historical record. The texture of the device is a mosaic of genius and decay. Even in its fragmented state, you can see the faint traces of Greek inscriptions etched into the bronze plates, serving as a sort of user manual for the cosmos. It was designed to track the movements of the sun, the moon, and the 5 planets known to the ancients with terrifying accuracy. It could predict eclipses decades in advance, even accounting for the wobble in the moon's orbit. This isn't just a clock, it is a mechanical computer that digitized the heavens into a handheld box. Here is where it becomes unsettling for modern engineers. When we try to replicate the mechanism using modern CAD software and 3D printers, we find that the logic behind the gear ratios is hauntingly efficient. The builders used a specific mathematical sequence to simulate the irregular motion of the moon, a concept known as epicyclic gearing. We used to believe this was a Renaissance invention, but here it is, sitting at the bottom of the Mediterranean Sea for 20 centuries, proving that the ancients had mastered the mathematics of the solar system long before they had the telescopes to see it. And this is the part most people miss about the discovery. It isn't just that they built it, it's that they had the need to build it. To create a machine this complex, you must have a society that values long-term astronomical prediction more than almost anything else. It suggests a culture where the celestial and the mechanical were fused together. But if the Greeks could build a computer in 100 BC, why did they stop? Why didn't they use this technology to build steam engines or automated factories? As you zoom in on the smallest fragments, you notice something even more disturbing. The gear teeth aren't just triangles, they are precisely angled to minimize friction. This requires an understanding of metallurgy and mechanical wear that we didn't think existed in the ancient world. When modern scientists attempted to build a working model, they struggled to align the pins and slots that allow the gears to slide and track the moon's varying speed. It is a masterpiece of miniaturization that defies the tools we thought they had. But think about the silence that followed this device. For nearly 1,500 years after the ship sank, there is a total vacuum of similar technology. It's as if a 747 jet engine was found in a medieval castle. The existence of the Antikythera mechanism suggests that history is not a steady climb upward, but a series of peaks and violent crashes. We are looking at the remnants of a peak that was so high, it took us 1,800 years to climb back up to that same level of mechanical complexity. The mystery of the missing tools is what keeps modern researchers awake at night. To carve bronze gears with this level of accuracy, you would ideally need a lathe or a precision filing system.
yet we find no such tools in the archaeological record of the time. We have the output of a high-tech society, but we are missing the infrastructure. It is like finding a modern smartphone, but having no evidence that electricity or factories ever existed. It forces us to ask if there was a different path to technology, one that didn't leave the same footprint as our own. Deep expansion into the wreck itself adds another layer of unease. The ship carrying the device was a massive Roman freighter, likely filled with looted treasures heading for a victory parade in Rome. The Antikythera Mechanism wasn't being sent to a university or a laboratory. It was being treated as a piece of art, a trophy of a conquered civilization. This tells us that by the time the ship sank, the knowledge to build these machines might have already been dying out, turning the most advanced technology on Earth into a mere curiosity for the wealthy. Modern engineering struggles to explain the differential gear found in some reconstructions of the device. This is a component that allows two different speeds to be combined into one, the same technology used in the axle of your car today. To think that a Greek philosopher could conceive of this mechanical logic while sitting under an olive tree is staggering. It suggests that their minds were already working in the language of algorithms and data processing, even if their energy sources were limited to wood and muscle. Conversational flow often brings us to the question of what else is down there. If one such device survived by a miracle of being buried in silt, how many hundreds of others were melted down for swords or jewelry over the centuries? The bronze of the ancient world was a precious commodity. Most of the high technology of the past was likely recycled into the weapons of the future, leaving us with a skewed view of what our ancestors were actually capable of. We see their temples and their statues, but we missed their machines. Here is where the implication becomes truly haunting. If the Antikythera Mechanism had not been lost in that storm, if that ship had reached Rome and the technology had been studied and replicated, the Industrial Revolution might have started 2,000 years ago. We could have reached the moon by the year 1000 AD. The device is a physical reminder of a lost future, a branch of the human timeline that was snapped off and thrown into the sea. As you look at the green, fractured remains in the National Archaeological Museum in Athens, you don't just see a relic, you see a challenge. It is a device that forces us to be humble about our own place in time. We like to think of ourselves as the pinnacle of engineering, but the Antikythera Mechanism proves that we are just the latest group to rediscover what was already known. It is a silent witness to a level of genius that we are only just beginning to translate. The final mystery lies in the lost manuals. The inscriptions on the device refer to other cycles and other planets that aren't even represented on the surviving fragments. This means the machine was even more complex than the 82 pieces we have recovered. It was a total map of the known universe rendered in metal. In the end, the Antikythera Mechanism remains a beautiful, terrifying enigma. A message in a bottle from a civilization that was much, much closer to the modern world than we ever dared to imagine. Every time we turn a gear in a modern watch, we are echoing the ghost of a Greek engineer who solved the same problem 2 millennia ago, alone in the dark, with nothing but a chisel and a dream of the stars.